mean is, all right, I'm going to phrase it. When you have a polygon whose vertices all touch the edge of a circle, they call that inscribed. An inscribed polygon means it's inside of a circle and all the vertices touch the edges of the circle. Now, in this case, it was a square. And when you have a square, obviously you've got congruent sides. If you've got congruent sides, that means these guys become chords, which meant that each of these chords on each of those arcs then were also congruent, which meant that all four of them equal 90. Now, what changed then, what's going to change ever so slightly today was that, remember I think we had, if this was A, B, C, and D, what was the measure then of arc A, B, C? What's the measure of arc A, B, C? It's 180. Everybody see that? The reason that it's 180 is because if I go from here to here, the diagonal of a square is the diameter of a circle. You all right with that? Now, look at then, by this being 180, like Josh said, since these are all 90 degrees here and here, watch what happens. This angle here, angle D, is on the circle. Since it's on the circle, we say that it is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. Okay? It's exaggerated for importance. Now, when you're on the circle, your vertex lies on the circle, you are inscribed. Now, when you have that, watch what the chords that create it continue outward. You guys okay with that? Those chords intercept an arc. Remember we talked about that yesterday? The intercepted arc was that. That arc measured, like Josh said a second ago, 180 degrees. What does the angle measure though? Equals 90. What's the relationship between 90 and 180? It's half of it, isn't it? Okay, it's half of it. One of the other things, if you guys remember when we did constructions, one of the first constructions that we did is we did a hexagon. Remember how we did the hexagon? We made the radius of the circle and we marked off all the tick marks going around it. Now, when we did that, let's see how I can do this one. We did have something very similar to this. Now, let me group this and pull this up. We've got to do a bunch of things like that. We've done shaded region with this and everything. Now, when you have what's called a regular hexagon, again, that means that all of your chords are the same, which then meant that all of our arcs were the same. How many chords or arcs are there in this diagram? There's 6 of them. If each one of them is the same, what does each one of them measure? 60. 60. Okay, they all measure 60 degrees. So if these are all 60s, do you agree that this angle here is on the circle? Okay. Now, when we did this before, we would take our three-sided figure and we'd figure out our outside angle. When we did that for the outside angle, what was our outside angle? It was 60, which meant that the inside angle would have been 120. You guys were getting ahead of yourself because then we would bisect it and go from there. But for right now, we know that this angle is 120. You okay with that? That's nothing new, is it? Now watch what happens. As you had your chord, the chord connects to here, and it hits here. How many degrees of the circle does it hit? 240, doesn't it? What's the relationship between 240 and 120? Well, yeah, they had 360, but it's half of 240, isn't it? Yeah. Are you sensing a pattern?
Yeah. So if you get 4 angles and then you leave the 2 angles, the 2 angles will add up to the 4 angles.
I think you're just making stuff up now. Well, that's how you get your arcs. If it's a regular polygon, yes, that's how you get all your arc stuff. That's what we've done before. But what happens here for the what's called an inscribed angle is that you get this thing when you have an inscribed angle. An inscribed angle. Oops. So actually press the button. Anytime you have an angle, I'll get this to work today. On the circle. This angle here is always equal to half of that arc. The inscribed angle, the angle is always equal to half the measure of the arc it hits. The measure of the angle will always equal half of the arc that it hits.
So an intercepting arc, is that
Yes.
the term?
Yeah, the intercepting arc. Whatever angle you have, when it hits the other side, it will always be equal to half of that angle. This is so lucky. Now, let's say that arc right there is 144. If the arc is 144, what's the angle? There you go. The arc is 144. That therefore makes the angle. And if you have the angle, what do you do to it to get the arc? There you go. Okay. So inscribed angle, the measure of the inscribed angle equals half the arc it hits, or double the angle to equal the arc it hits. It does work. Mr. Order of Operations. Don't lean in your chair, Josh. I told you that twice yesterday. I tell you one more time, you will stand. Okay? So don't lean in your chair.
This is like a habit.
We'll break the habit. Very easy.
What's our fault?
Anyway, so again, the angle is equal to half the arc that it hits. So if that angle is 50, what's the arc? Great for math today, huh?
This is all we doing today?
Well, yeah, obviously you can throw algebra and all that other stuff to it too. So it's not like the concept here is pretty simple. Now, there's enough information here to figure out all the angles that you see and all the arcs. By giving just this little bit of information, you have enough to solve for the angles and for the arcs. So let's take a second, draw it, follow what you're writing, follow your sides to make it all work. What does BC appear to be in this problem?
A line.
No, diameter. It's not a line. It's a diameter. If that's a diameter, that means it cuts the circle in half. Well, if this is 50, what's the arc over here? 100. Okay. That gives me 100 here, which means arc AB is, which gives me 48 to here, which is, and then how many degrees are here? See how quick that is? Again, you're using very, very, very simple stuff to solve problems. Okay? A lot of times with these things, it really, as goofy as some of this stuff gets, is going to be literally falling to the wrong line, or mixing up a number, or instead of dividing, doing 180, you might accidentally do 200. Something stupid like that. Okay? So it shouldn't be very, very tough. Let's try that one. If two inscribed angles of a circle intercept the same arc, those angles have to be congruent. I mean, if you think about it, when you have a circle, oops. If you have a circle, say we have one that goes here to here, I have one from here to there. Don't these two angles hit the same arc? So by rule, if that arc happens to equal, well, I think it's a little bit less than 100. Let's say it's 84. If that arc is 84 degrees, by rule, what does both of those angles have to equal? 42. They both have to be 42. It doesn't. Each of these is a different angle, so I'm not bisecting anything. So half of 84 is 42. Well, if the angle was, if I double the angle to get the measure of the arc, that arc length, if I double 42, I get 84. You're taking it too far. But remember, Josh, these two angles, they run into the exact same arc. Right, you don't have to worry about any of that. When I'm looking at, no matter where I put an angle, if I put that angle there, that angle's still got to equal 42 because it's intercepting the exact same arc. As long as it's hitting the exact same arc, doesn't matter where it is on the circle, that value is always going to be half of whatever arc it hits. Thank you. It's like my personality. Shut up. Guess I'll get this kind of abuse in anywhere else. Maybe Solomon. So. No, not really. Nope. Don't know a lot. All right. Didn't meet him that day. And two snakes and a sticker. We had a word problem the other day. How many distinguishable ways can you arrange 3 Labradors, 2 Chihuahuas? Okay. Again, is there enough information to solve through everything? Okay, solve through everything. Find every angle, find every arc. That's kind of what we're going to be doing. Every angle, every arc.
I said,
Which one? Oh, if two angles hit the same arc, they're no problem. Jeremiah, you're tall, you can reach that. Go right on those answers for me.
use the eggshells.
What? Now you look at it.
And then arc DC, make sure you put your degree symbol, otherwise I'm like 50 what? 50 ducks.
50 ducks. Sure. Like I said, super easy. Super, super easy. Okay. I don't need to do this. We just did this one. It's the other one. Did this one. We did that. Okay. So here's the one other part that we didn't talk about. Anytime that you have a right angle that is on, or a right triangle, if the right angle is on the circle, that means it has to intercept the diameter. Because if you're a right angle on a circle, what is the measure of the arc that you hit? Well, the angle is 90, which means the arc has to be 180, which means no matter what, you have to hit a diameter. And that goes for wherever you place it. And that's why that problem earlier today I showed you with the square, that's why that works. Because it has to work.
Is the diameter.
Oh. Sorry. Didn't have to proofread my handwriting. Try to be all fancy and I type something in real quick. And it's hypotenuse of the. They sound like that. I don't know. Anyway, so as you go through this, this has to make sense because no matter what, anytime you put a right angle, whenever you put a right angle on a circle, if it's going to be, if that's going to be 90 degrees, that means that it has to hit, that has to be, oops, it has to equal 180 on the other one by rule. Okay? Yes, sir. For here? Yeah. Yep. Because right in this case, we're making up the square. Now, excuse me. Let's see, what was the other one in here? Much stuff left here. A quadrilateral. Now, this again is really, really, really easy. The quadrilateral, ooh, I wrote that badly. This is What this is saying is that quadrilaterals can be inscribed in a circle if and only if the opposite angles are supplementary. If opposite angles are supplementary, that means they have to add up to equal how much? 180. So basically, in short form here, it means that angle A plus angle C is 180, or angle B plus angle D is 180. That's why when you have two things that are equal to the same thing, you can set them equal to each other. That's that substitution set that we talked about back when we did proofs. So you can still work backwards off of problems like that as well. So whenever you have a quadrilateral, remember a quadrilateral has how many sides? 4. So if you know one of the angles or two of the angles, you can kind of work your way through to get the other ones. It's not going to be crazy difficult. It's just some very simple algebra that we've pretty much have covered, I don't know, 2 or 3 times, maybe 4, something like that. For example. Waiting, sorry. Need to get ahead of you. Remember, IFF stands for if and only if, which means if you say it backwards, if opposite angles are supplementary, then a quadrilateral has been inscribed in a circle. This means it's go forward and backwards with those. If a right angle lies on a circle, a right angle lies on the circle if and only if its hypotenuse is a diameter. If a hypotenuse is a diameter, then the right angle lies on the circle. Same idea. You can say things forwards and backwards. That's why a lot of times in the problems you guys see, they'll ask you, instead of just solve for x, it'll have to say, hey, this is x, why does this work? And you work backwards because of the inconvenience. So real quick, in this case here, we've got the quadrilateral. I just kind of cut and paste the exact same quadrilateral. In order to solve for x and y here, well, what do you have to do? I mean, yeah, see how quick this is? In order for these guys, in order for this to be inscribed, in order for this to work, the value of x and y means, well, 100 plus x has to be 180. Same thing with y plus 60 has to be 180. And it winds up being super fast one-step math. Subtract out, you get 80. Subtract out, you're going to get 120. Right. Obviously, you might have like 3y plus 7 equals, plus something else equals 180. You might have to do 2 steps. But it isn't going to be anything on a level that you guys haven't done before. Excuse me. What's that? Yeah, right? I know. There's, like I said, this one isn't so bad. We might be able to get through a little bit extra with this one and a few more problems. That's a 19. Do this last one, and I think we might just call it a day.
Bless you. Bless you. Bless you.
Take it a step further and find all the angles, please. Oh, I'm such a jerk. I know.
It's 105, 75.
You got 15 for y. Substitute in, that means this one is what, 95, I think? And then this is 75. Okay. And then the other one, we have 17x, 19x, 180. That gets you, what, 36, I believe? That's what, 5? Substitute back in, you're going to get times 5 is what, 95? Wait, should be 85 and 95. Thank you. Say, wait, that doesn't work. Well, it should be 85 and 95 because that doesn't. Then these aren't supplementary. Right? So this is the 70. Yeah, this is 75. So this would be 10 more. Wait, no. Why am I screwing this up? 5. I should just use a calculator. What's that? And then this one's 85. Yeah. Hey, guess what, ladies and gentlemen? 5 times 7 isn't 25, it's 35. Sorry. I did the same thing here, didn't I? Man, why can't I math? Yeah, duh, 3, 105. I did the same thing. Apparently, my brain thinks 7 times 5 is 25. So, apparently. Yeah, womp, womp, womp. Sorry, it is past the return date. You'd only get SOAR credit. No. Josh, stand up. Stand up. Stand up. Stand up. You can't sit in any chair. Nor can you sit. You can sit on the floor. You can't sit on the desk. You can sit on the floor. So if you want to sit on the floor, by all means, man, I have no problem with that. No.
I'm gonna pace.
And if you need to pace while you're doing your homework, because you said you're getting your homework done before you leave today. Again, I'm going to use some of the older stuff. It's got a little bit extra algebra to it. Well, again, don't freak out. It's not like just go knock this out. All of these, not a big deal. Yes, please. Yes, sir. Get rolling. Like I said, this should not take very long. But here's the deal, guys. You got to show your work. Got to show your work. Yeah. Okay? Yes. I'm giving you about, what? Okay, enough. You guys have almost 20 minutes to get started. If you don't complain, you could probably get the entire thing.